So one of the applications of matrix multiplication is in showing that your inverse of the matrix really is the inverse for that matrix, because the definition of the inverse is that A inverse will give you the identity matrix, and also if you left multiply by the inverse, so A inverse A will give you the identity. So you actually have to show both of them, and whether you talk about A or B, it's all the same. So what I would do is I'd multiply these two together. So 1, 0, negative 1, 1, and then 1, 0, 1, and 1. And again, we have a 2 by 2 matrix multiplied by another 2 by 2 matrix. So that is going to give us a 2 by 2 matrix. Okay, so for the row 1, column 1, we'll be taking 1 times 1 and then adding that to 0 times 1, which of course is just going to leave you as 1. Then for row 1, column 2, we'll be taking row 1 times, or 1 times 0, so that gives us 0, plus 0 times 1, which gives you 0. Then for row 2, column 1, we'll be taking row 2, multiplying that by column 1. So here we do have to be a little careful. We have negative 1 times 1, so that gives us negative 1, and then added to 1 times 1, so that will give you 0. And then for row 2, column 2, you'll be taking negative 1 times 0, so that gives you 0, and then adding that to 1 times 1. So at the end of the day, it does give you the identity matrix as follows. Now, just because that multiplication worked out does not mean that it's the inverse. You also have to do the other multiplication. So you basically have to do like B inverse. So what you do here is you take the 1, 0, 1, 1, so flip the order of these matrices, and then 1, 0, negative 1, 1, and multiply together. So again, you have your 2 by 2 multiplied by another 2 by 2. It will give you a 2 by 2 matrix. So you'll have 1 times 1, and then added to 0 times negative 1, which just gives you 0. So it will end up with 1, and then 1 times 0, and then added to that 0 times 1 gives you 0, and you will verify that yes, that does give you the identity matrix. So because both directions, left and right multiplication, give you the identity, that is the inverse of the original matrix.